Greetings, Skywatchers. Can you imagine it? Envision a cosmic phenomenon so immense that it casts shadows on our planet, perceptible even during the day. That's the marvel we may be on the verge of observing in the Orion constellation. The star Betelgeuse is behaving peculiarly, suggesting an impending supernova explosion that could illuminate our sky like never before. But when will Betelgeuse undergo a supernova, and what will it appear like? What insights might this stellar occurrence reveal, according to scientists? Join us as we explore the intricate details of what's unfolding with Betelgeuse and the potential ramifications for Earth and perhaps the entire solar system. Situated roughly 650 light-years away in the constellation Orion, Betelgeuse is not just an ordinary star. It's a red supergiant, among the most radiant stars known to humanity, shining with a brilliance over 100,000 times that of our Sun. But why is this red giant so significant to us? Betelgeuse stands out not only for its luminosity but also for its historical and cultural importance. Named after the Arabic phrase, Yad al-Zaw, meaning the hand of Orion, Betelgeuse has been observed and chronicled by ancient civilizations for centuries. It has served as a guide for adventurers and a source of awe for stargazers, its reddish glow distinguishing it from other stars in the Orion constellation. Can you envision a single star overshadowing our entire solar system? To illustrate the vastness of Betelgeuse, if it were positioned where our Sun is, its outer edges would reach all the way to Jupiter. How can one star attain such enormous dimensions? At 10 million years old, it's significantly younger than our 5 billion-year-old Sun, but Betelgeuse's colossal size means it consumes its resources at a much quicker rate, predicting a shorter lifespan than other stars. Now, this celestial giant, occupying a volume capable of containing over 1 billion of our suns, is approaching the conclusion of its life cycle. When stars of such magnitude enter their final stages, they don't merely fade. They conclude with a cataclysm, a supernova explosion of unimaginable energy and brilliance. Such an event could outshine entire galaxies, casting dazzling shadows across vast cosmic stretches. The last time Earth experienced a supernova this near was in 1604, long before the advent of modern telescopes. This event, referred to as the Kepler supernova, was the final supernova to be witnessed in our Milky Way galaxy with the naked eye, remaining visible for more than 18 months. It was brighter than any other star in the night sky and could even be seen during the day for several weeks. What enigmas do these stellar remnants disclose to us? Ancient accounts from various cultures, including Chinese and European astronomers, documented the appearance of this new star. Interestingly, remnants of this explosion, in the form of an expanding debris cloud, can still be observed today with advanced telescopes, providing insights into the violent endings of massive stars. Historically, supernovae have been infrequent observations on Earth, but imagine for a moment a stellar explosion so intense that it rivals the brightness of a full moon, casting shadows on Earth at night and being visible during daylight. The radiation from such an occurrence would energize our atmosphere, potentially affecting satellite operations and possibly even the climate. Betelgeuse, with its erratic dimming patterns, suggests it may be preparing for such a grand spectacle. Could we be on the brink of witnessing one of the universe's most dramatic occurrences? Recently, astronomers made a shocking discovery. Between October 2019 and early 2023, Betelgeuse underwent a remarkable transformation that captured the attention of astronomers and enthusiasts alike. Known as the Great Dimming, the star's brightness, which had remained stable for centuries, began to decline significantly. This sudden change was so apparent that even casual skywatchers noticed it when comparing Betelgeuse to other stars in the Orion constellation. This suggests that we're not just centuries away from witnessing its supernova explosion, but perhaps only decades or even sooner. By April 2023, astronomical observations indicated that Betelgeuse had returned to its usual luminosity levels, leading many to believe that the anomaly had concluded. In a surprising turn, the following months saw Betelgeuse's brightness increase by an astonishing 50%. Such significant fluctuations, while typical of variable stars, were unusual for Betelgeuse, which had primarily displayed consistent luminosity cycles. The sudden and dramatic surge in its brightness thrust the star back into the spotlight, igniting discussions about its immediate future. But what triggered this abrupt change in brightness? Why did Betelgeuse, one of the most recognizable stars in our night sky, suddenly present a cosmic surprise? Stars are not merely twinkling points in our night sky. They are dynamic entities with life cycles, activities, and mysteries of their own. For many celestial bodies, periodic brightness changes can be anticipated, much like the rhythms of Earth's seasons. Throughout its stellar life, Betelgeuse has maintained a fairly stable 400-day luminosity cycle. However, with the Great Dimming, it appeared to defy its established behavior, challenging our understanding of the celestial phenomena above. Now you might be asking, are we on the brink of a stellar revelation? While the exact reasons for Betelgeuse's irregularities are still under investigation, a compelling theory has emerged. This theory, focusing on stellar activity and mass ejection, paints an intriguing scenario. Imagine Betelgeuse as a colossal celestial volcano, subtly erupting and expelling a vast amount of its material into space. Previous observations from the Hubble Space Telescope indicated that Betelgeuse had previously expelled a tremendous amount of its surface material into the cosmos. This expulsion, a monumental event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our Moon. Such events can result in the formation of a dense dust cloud around the star, affecting its apparent brightness and temporarily making it more challenging to observe. Then, as this dust began to disperse or was pushed away by the force of the star's radiation pressure, the obscuration lifted. This could clarify its subsequent return to normal brightness levels. Either way, these recent occurrences suggest a star that's not finished surprising us. Many speculate that Betelgeuse might be nearing the twilight of its existence. A supernova event, an astounding burst of energy that can momentarily outshine an entire galaxy, occurs when there is a sudden shift in the star's core. Such changes can arise if a star absorbs too much material from a neighboring star, or in Betelgeuse's case, it could be due to the depletion of its nuclear fuel, which causes its mass to collapse into the core, setting the stage for a cataclysmic collapse. But what propels a massive star like Betelgeuse toward its end? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse begin their journey by burning hydrogen in their cores. This initial phase, known as the main sequence stage, lasts for millions of years and forms the foundation of a star's life. However, as stars deplete their hydrogen, they evolve, adopting new energy sources. In the case of Betelgeuse, as the hydrogen diminishes, it starts to burn helium, resulting in the formation of carbon and oxygen. This transition from the main sequence phase to the helium-burning phase is characterized by the star's expansion into a red giant. Over time, as helium reserves dwindle, the star undergoes further expansion and transitions into other burning phases, each defined by the fusion of progressively heavier elements. The larger the star, the quicker these transitions occur, given the immense gravitational forces at play. Then comes the climax when iron starts forming at the core. Unlike lighter elements, iron doesn't release energy when fused, so the energy produced is insufficient to counteract the star's own crushing gravity. The star swells in size, creating an implosion, followed by a tremendous rebound effect, resulting in the explosive force of a supernova. So, is Betelgeuse on the verge of an explosive end or merely biding its time? Recent research from Japan's Tohoku University suggests that the star might currently be in its carbon-burning phase. Lead researcher Haddock believes that the core may collapse a few decades after its carbon reserves are exhausted. However, not all scientists agree. Contrasting studies from Hungary's Konkoly Observatory speculate that Betelgeuse is still in the earlier helium-burning stage. The one consensus among scientists, regardless of these debates, is that Betelgeuse is poised to become the Milky Way's next supernova. Yet, determining the timing of this event remains a cosmic guessing game, with predictions ranging from mere decades to 100,000 years. Amidst these scientific discussions and speculations about Betelgeuse's fate, one fact remains undisputed: the very nature of our observations. When we gaze up at the starry expanse, there's a subtle paradox we often overlook. This paradox is rooted in the fundamental nature of time and light. In our vast cosmos, Stars and celestial bodies are so remote that their light takes a monumental amount of time to reach our eyes. For example, although the speed of light is an astounding 186,282 meters per second, it still has its limits. Consequently, the light from distant stars and galaxies takes considerable time to traverse the vastness of space before it reaches our sight. When observing Betelgeuse, you're essentially witnessing a spectacle from 650 years in the past. To contextualize this, when this very light began its journey toward Earth, the Renaissance was just beginning, and explorers like Marco Polo were making their mark in history. Every observation we make of Betelgeuse is akin to peering through a cosmic time capsule, providing insights into its distant past. If, hypothetically, Betelgeuse had already exploded in a spectacular supernova, we would remain unaware for another 650 years. So while we speculate and anticipate its impending supernova, somewhere out in the vast cosmos, this monumental event may have already occurred. We're simply waiting for it to traverse space and time until it reaches our eager telescopes. The recent revelations surrounding Betelgeuse have ignited fervent discussions within the astronomical community, with parallels being drawn to another sensational discovery from earlier this year, SN 2023X. This recently observed supernova, occurring in a galaxy neighboring the Milky Way, reminded many of the fascinating dynamics and unpredictable nature of the universe. SN 2023X was unique in its own right. Situated several million light-years away, it exhibited an intense display of brilliance that briefly outshone its host galaxy. What made it particularly intriguing to scientists and casual observers alike was its uncanny resemblance to what many predict will be the destiny of Betelgeuse. The spectrum, intensity, and aftermath of the explosion provided a tantalizing glimpse into the processes these massive stars undergo as they near the end of their life cycles. For many, SN 2023X served as a preview of if and when Betelgeuse meets its explosive fate. The sequence of events may mirror what was witnessed with SN 2023X. Moreover, the connection between these two celestial events highlights a broader theme about the interconnectedness of our universe. Whether it's a neighboring star like Betelgeuse or a distant supernova such as SN 2023X, these cosmic phenomena remind us of the dynamic and evolving nature of space. Beyond the tangible and scientific, the explosion would have significant effects on human culture. The sky, observed and cherished for millennia, would change, prompting reflections on impermanence, the vast scales of cosmic time, and our place in the universe. Such cosmic wonders remind us of the fleeting nature of existence and our eternal quest to understand the great beyond. As we contemplate the potential supernova of Betelgeuse, it's crucial to recognize the broader implications of such an event on our cosmic neighborhood. When Betelgeuse finally meets its explosive end, it could influence not only our immediate vicinity in the Milky Way but also the dynamics of the interstellar medium. The shock waves generated by the supernova will create vast regions of ionized gas, enriching the surrounding space with heavier elements synthesized during the star's life cycle. This process plays a vital role in the cosmic cycle of matter, seeding new stars and planets with the essential ingredients for life. Additionally, the light from the impending explosion could serve as a natural laboratory for astronomers. Observing the light curve and spectral features of the supernova could yield unprecedented data on the life and death of massive stars. Each supernova provides a unique glimpse into the physical processes at play, revealing how energy is distributed in such cataclysmic events. By studying these phenomena, scientists can refine their models of stellar evolution, contributing to our understanding of the universe's life cycle. Alongside scientific advancements, a supernova can have cultural repercussions. Historically significant astronomical events have influenced art, literature, and philosophy. The brilliant appearance of Betelgeuse would likely inspire a new wave of artistic expression and reflection. People around the world would gaze at the night sky, contemplating their place in the cosmos. This event could spark a renewed interest in astronomy and science, much like the fascination that emerged during the Renaissance when celestial observations began to reshape our understanding of the universe. From a practical standpoint, the effects of a supernova could extend to technology. Increased radiation levels from such an explosion could pose challenges for satellite communications and navigation systems. These implications would necessitate advancements in shielding and protective technologies, further pushing the boundaries of engineering in space exploration. As we continue to rely more heavily on technology, understanding these cosmic events becomes crucial for mitigating their impacts on our daily lives. The supernova could also alter our perception of time itself. The fleeting nature of such an event serves as a reminder that even the most colossal celestial bodies are not eternal. This realization may provoke philosophical discussions about existence and the transitory nature of life. The universe operates on timescales that dwarf human life, yet we find meaning in our brief moments under the stars. In conclusion, as we await the inevitable fate of Betelgeuse, we are reminded of our connection to the cosmos. Each twinkling star tells a tale of its past, and Betelgeuse, with all its mysteries, invites us to reflect on our place in the grand tapestry of the universe. Whether it erupts in a supernova tomorrow or in a millennium, it will continue to inspire wonder and curiosity in generations to come.